video, we are going to be working on multiplying mixed numbers with generic rectangles. Now, the first thing we're going to do is start by doing an example of a generic rectangle. So, in my example, we have 24 times 33, and I already have the generic rectangle set up for you. And how we set this up is we're breaking apart the 24 and the 33 into tens and ones. So the 24 becomes 20 and 4, 20 plus 4 is 24, and 33 becomes 30 and 3, 30 plus 3 is 33. So that's the setup. And then we start, and we're actually finding areas. We're finding 4 areas, and we're going to add it together. So we start with 30 times 20, and I actually like to do 3 times 2, and I get 6. And then I add however many zeros I have, and that would be 2. So my answer is 600. And I'm going to put that there. Then I will go down to this one. I have 30, because that is that length, times 4. 3 times 4 is 12. And I have 1 0. And over here we have 20 times 3. 3 times 2 is 6. And I'm going to add 1 0. And at the bottom I have 3 times 4, and I get 12. So then in order to find the total answer, I need to add up all the areas. So I need to do 600, and I have to be very careful when I line them up, plus 120 to make sure I'm lining up place values correctly, 60, and 12. So I'm adding. So 0, 0, 0 plus 2 would be 2. 0 plus 2 is 2, plus 6 is 8, plus 1 is 9. And then 6 and 1 is 7. So my final answer is 792. So there is example 1. Then we're going to actually go on to do one with mixed numbers. And since we know how to multiply fractions, this is going to be very simple, especially using our generic rectangle. So again, we have 4 2/5 and 2 1/4. That is our problem. I already have it set up. I have the 4. I'm breaking it up into whole numbers and fractions. So 4 and then 2/5 and 2 and the 1/4. If you add those sides together, you get these numbers up here. So we're going to start small. 4 times 2 is 8. Then we have something a little bit trickier. So now we have 4 times 1/4. Now I'm actually going to show you these calculations. So we have 4 times 1/4. Now something that might be nice to remember is that 4 is really the same as 4 over 1. 4 wholes. So what I have is 4 over 1 times 1 over 4, and I'm actually just doing 4 times 1 to get 4, multiplying my numerators, and then my denominators. 1 times 4 is 4 again. So 4 over 4 is actually just 1. So I could put it in there either way. I'm going to put it in there as a 1. But that is where that came from. Then, and I'll change to a different color, I'm going to do 2/5 times 2. And I'm going to again remember that 2 wholes can be written as 2 over 1. So it's going to be 2/5, or 2 over 1 times 2/5. And that is equal to 4/5. So that's going to go here. And then our last one, 1/4 times 2/5. Again, multiplying our numerators, 1 times 2 is 2. Multiplying the denominators, 4 times 5 is 20. I get 2 over 20, and I can simplify that. I know 2 goes into both, so I have 1/10. And what I need to do is add all of these numbers together. So I have, I'll do it over here, 8 plus 1, and I get 9. And I know that I need to add my fractions together. So it's going to be easiest if I do 4/5, add those separately, plus 1/10. Now when adding, I need a common denominator. So I need to change this fraction, and I can easily do that. 5 times 2 is 10. So I'm going to use my giant 1. And inside my giant 1, I'm going to get 2 because I'm trying to get 2, 10. 4 times 2 is 8. So I'm going to change this up here. And I'm going to get 8 over 10 plus 1 over 10 is 9 over 10. So then I need to add that number and that number together, and I get 9 and 9/10. And I know this is a lot of steps, but these are all steps that you know, so it's just reviewing a whole bunch of different things that we've been working on this year. So we will do another example. Example number 2, we have 5 3/8 times 1 1/2. And again, I've already set up the problem. We have 5 3/8, we have 1 1/2. And we'll start here. 5 times 1 is pretty simple, 5. 1 times 3/8. This is really nice because we don't even have to do any calculations. 1 times 3/8, anything times 1 is itself, so this answer is going to be 3/8. Okay, so then we have 5 times 1/2. 5 wholes is 5 over 1 times 1/2. Again, not too bad. We have 5 over 2. Or if you want to use decimals for this one, 2.5. And then we have 3/8 times 1/2, and I'll do this over here. 3 over 8 times 1/2. Multiplying my numerators, I get 3. Multiplying my denominators, I'm going to get 16. So I have 3/16. Alright, and now I need to add all of these numbers together. And I'm going to add up all my fractions first. So these 3. I have 5 over 2 plus, and I'm going to make myself a little more room. I have 5 over 2 plus 3 over 16 plus 3 over 8. Now this is fantastic because we have 2, 16, and 8 as our denominators. Well, 2 times 8 is 16, so I know that all these numbers work really nicely together. So 5 over 2, my giant 1 is going to have an 8. And 5 times 8 is 40. And then 16. And I'm going to change this one as well. 3/8 inside my giant 1 is a 2. 3 times 2 is 6/16. So I'm going to rewrite this problem so that I have all common denominators. I have 40/16 plus 3/16 plus 6/16. 40 plus 3 is 43, plus 6 is 49. Okay, so I have 49/16 is the fractions all added together, so we have as well that 5, but first I want to figure out how many times 16 goes into 49, and that is 3 whole times, and 3 times 16 is equal to 48, and we have 49, so there's going to be 1 left over, so this is really 3 1/16. And then we have to remember to add 5 to get our final answer. So we have 3 1/16 plus 5. 5 plus 3 is 8. And then we have 1/16 as our final answer. So again, a lot of steps, but all things that you know how to do. Feel free to use the multiplication chart to help you with some of the multiplication and turning your improper fractions into mixed numbers. And that should do it. If you have any questions, make sure to come with those into class tomorrow.